This is the 63rd video on Newton's laws of motion. This is in continuation of the 62nd video. In this video also I'll take up a numerical problem on Newton's second law. A numerical problem will be taken up based on Newton's second law. Okay. So I'll draw the diagram of the situation. Diagram is this. Here we have a massless pulley, okay, say P1. This is center C1 of pulley P1 on which a force F is being applied, time dependent force F is being applied in upward direction. A massless string S1 passes over pulley P1 and here there is a block which is placed over a fixed horizontal surface. Okay. Now this string S1 passes over pulley P1, is in contact with this block, and this string S1 is attached to another massless pulley P2. C2 is the center of pulley P2. Okay. And here there are two blocks like this. This is the string S2. This is a fixed horizontal surface. Okay. This is pulley P1, this is pulley P2. This is the string S1, this is the string S2. Both the strings are massless and inextensible, and there is no friction anywhere between the string and the pulley in contact. Here we have three blocks, B1, B2 and B3. Alright. Mass of B1 is given to be 2 kg. Mass of B2 is given to be 3 kg. And mass of B3 is given to be 6 kg. Okay, fine. A time dependent force F is applied to center C1 of pulley P1 in upward direction by means of a string, another string S3. Okay. F depends on time as F equal to 8t. Small t denotes time. Alright, fine. Now the question is, find the velocity of the three blocks B1, B2, B3 with respect to ground as a function of time. Find of the blocks B3 with respect to ground, G for ground, as a function of time t, small t. Okay, this is the question. Fine. So now we have to take G to be 10 meter per second square. Okay. So now where do we start the problem from? See, this string S2 is massless and there is no friction between string S2 and pulley P2 in contact. So at a given instant, tension at all points of S2 is same, say T. Here also it is T. Okay. Now this pulley P2 is massless. So tension at this point of the string will be 2T. Now S2 is string S1 is massless and there is no friction between string S1 and pulley P1 in contact. So tension at all points of string S1 is same, say 2T. Alright. Now this pulley P1 is massless. So tension in the string attached to the block pulley P1 at C1 is simply 4T. Okay. So this 40 is just 8T. This means T is just equal to 2T. So tension in this string varies with time as T equal to 2T. And tension in string S1 depends on time T as 2T, 2 times capital T. Capital T is 2 times small t. So this is how tension in this string S1 is 4T. Alright, fine. Now, let us consider the three blocks separately. Okay. Let us consider the block B1. If you draw the free body, see the string S2 will exert a tension force T on the block B1 in upward direction. This is the weight 2g of the block B1. Okay. Now T is just equal to 2t as we have found just now. Now as time passes by, T goes on increasing. Time comes when 2t just exceeds the weight of this block B1. So when this happens, block B1 loses contact with the ground and begins to move up. Okay. So when T exceeds 2g implies block B1 loses contact with the ground. Okay. This is a surface, fixed surface, over which the three blocks are placed. This is a surface. Loses contact with the surface. Okay. When T equal to more than 2g, the block B1 loses contact with the surface. Now T is equal to 2t. So 2t exceeds 2g. Meaning T exceeds g. That meaning T exceeds 10 meter per second square. T exceeds 10 second. When T exceeds 10 second, then block B1 loses contact with the ground surface. Okay. And what if T is less than 10? More than 0? In this time interval, block B1 stays in contact with the ground. Okay. So, now we have to find the velocity of block B1 as a function of time. So, in that interval 0 to 10, velocity of block B1 with respect to ground is 0. Because in 0 to 10 seconds, the block B1 is in contact with the surface and is at rest. So, speed of block B1 is 0 till the time instant t equal to 10 seconds. When t exceeds 10 seconds, this block B1 begins to move up. Because then tension force exceeds its downward weight 2g. Okay. So now, I apply Newton's second law to block B1 in upward direction after the time t more than 10. Okay. So then it begins to accelerate up. So apply Newton's second law to block B1 with respect to ground in upward direction. Alright. So 2 dv1 by dt is equal to, t is simply 2t minus 2g. G is simply 10. So this means dv1 by dt is more than t minus 10. G I replaced by 10. Okay, 2 cancels out. Equal to, sorry. Okay, I shift dt that side. T dt minus 10 dt. Now integrate this on both sides with respect to time. What is going to be the lower limit of time t? It is going to be 10 seconds. Upper limit is t. Here also 10 to t. T equal to 10, v1 is 0. T more than 10, v1 is some value given. So I integrate this equation on both sides. v1 minus 0, that is simply v1. T dt becomes t square by 2. On inserting the limits, t square minus 100 by 2. Minus 10, this integrated one gives t minus 10. So this is the v1 as a function of time. This value provided t is more than equal to 10 seconds. This is one answer. Fine, alright. So one answer we have obtained now. Alright, fine. I rub this one. So this value provided t is more than equal to 10. In fact, more than 10. So what do you write? Complete answer for v1. v1 is 0 if t is less than equal to 10 second, more than 0. And v1 is equal to t square minus 100 by 2 minus 10 times t minus 10 if t exceeds 10 second. Okay, this is the first part of the answer. Alright, fine. Here. So one answer for B1 has been obtained. Okay. Now I take the case of B2. Now rub that side, okay. Now find the speed of, repeat the same thing for B2. Mass of B2 is given to be 3 kg and this is 6 kg. Now see, weight of B2 is 3 kg, 3g, 30 Newton in downward direction. T is here equal to 2t as I've just now found. So as T goes on increasing, I'll write it again, T equal to 2t. As small t time goes on increasing, T also goes on increasing tension. A stage comes when tension T just exceeds the weight 30 Newton of this block B2. At that instant, block B2 begins to accelerate upward. Okay. So block B2 just loses contact ground when T exceeds 3g, that is 30. That meaning 2t exceeds 30. This means T exceeds 15 seconds. When T exceeds 15 seconds, then block B2 loses contact with the ground surface. Now suppose V2 is the velocity of block B2 at time t. Okay. So now what do we write for B2? I apply Newton's second law to block B2 in upward direction for t more than 15 seconds. Alright. And what do I write? 3 dV2 by dt is equal to 2t. Tension T is 2t minus 3g 30. So now shift dt that side. Then what do we get? 3v2 equal to 2t dt minus 30 dt. Now integrate this equation both sides. 2t dt minus 30 dt. What are the limits of t? T will start from 15 and t. Lower limit of t is again 15, upper limit is t. For t equal to 15, v2 is 0. For t equal to t, it is v2. Now integrate this equation and insert limits. 2t dt becomes t square. I insert the limits. 225. Okay, fine. 2t dt becomes t square. So this is the limit, inserting limits. 30 into t minus 15. Okay. So v2 becomes t square minus 225 by 3 minus 30 by 3, that is 10 times t minus 15. This is the required answer. Okay. This is valid so long as t is more than 15 seconds. And then it is valid. Okay. So I'll grab this one now. One answer I have already written it here. So V2, complete expression of V2 is this. V2 is 0 if t is less than equal to 15 seconds, and V2 is equal to this much. This is valid when t exceeds 15 seconds. This is the second part of the answer to the question. Speed of block B2 as a function of time, it is this much. Okay, fine. So V2 becomes t square minus 225 by 3 minus 10 times t minus 15. Alright, fine. So these two speeds we already found out. Now I take the case of block B3. Okay, fine. I take the case of block B3. Tension in the string S1 attached to block B3 is 2T, that is simply equal to 4T. Okay. Weight of block B3 is given to be 6 kg. Its weight is 16 Newton in downward direction, G is 10. Now, as T increases implies 2T also increases. At certain instant 2T exceeds the weight 6G of the block B3. Then block B3 loses contact with the ground and begins to move upward. Block B3 begins to move upward when 40 exceeds 60 Newton, that is T exceeds 15 seconds. Okay, fine. Fine. So now I'll write down the apply Newton's second law to block B3 in upward direction for t more than 15 seconds. Okay. So let V3 be the speed of block B3 at time small t. Apply Newton's second law to B3 in upward direction. What do I write? 6 dV3 by dt, mass times acceleration, equal to net force 2t minus 6g, that is 60. But capital T is 2 times capital T is 40. 40 minus 60. Okay. Now I shift dt that side. 40 dt minus 60 dt. Okay. Okay. Fine. Now integrate this. Lower limit of t will be 15. Upper limit is t. Here also 15 to t. Here lower limit of v3 will be 0 when t is 15. Upper limit is v3. This I integrate 6 v3. 40 dt integrated becomes 2t square. T square minus 225. 60 times t minus 15. This is v3. T square minus 225 by 3 minus 10 times t minus 15. On dividing both sides by 6. This is valid only so long as t is more than or equal to 15 seconds. Okay. I love this one, alright. So what will be the complete answer for V3 be? V3 is equal to 0 if t is less than 15 seconds and more than 0. And V3 is equal to t square minus 225 by 3, 10 into t minus 15. This is valid if t exceeds 15 seconds. In this way, this problem has also been fully solved. So we have found the velocities of all the 3 blocks as a function of time. Okay. For all values of t, we have determined. Okay. So you have to carefully go through this problem. Okay. In case you have some doubt, put your doubt in the comment box. I'll explain it. Okay. So this was the 63rd video on Newton's laws of motion. Okay. So see, so many videos I have put on Newton's laws of motion. If you go through all of them very nicely, your concept will be cleared. And your problem solving ability will increase several orders of magnitude. Okay. So here I'll close it. Okay. Fine. All right.